Okay, this is a quick video to show you how a relay switch works and talk about what it does. So, a relay switch is a switch that's used to turn on and off usually a dangerous electric circuit by using a safe electric circuit, and it consists of two totally separate circuits. So there's one circuit which comes in and powers an electromagnet. So this is the input circuit that controls the operation of the relay. When current is supplied in this part of the circuit, it flows around the coils of wire, which you can see here in the diagram, and magnetizes the electromagnet being this whole part here. Now, when the current flows in this part of the circuit and the electromagnet becomes magnetized, this part here, which is called the armature, is attracted towards the electromagnet. So the armature has to have something that's magnetic attached to it in order to be attracted. So this part here that I've just shaded in is usually made of iron, so that the iron will be attracted to the electromagnet when it turns on. So when you switch on, let's call this circuit A over here, when you switch on circuit A, the electromagnet becomes magnetized and this armature gets attracted, and in that case it's going to bring this whole arm and contact thing down so it makes contact here. Now this is part of another circuit which I'll draw in blue, which we'll call circuit B, and the other end of this is going to connect up somewhere over here, so we'll call this circuit B. So for circuit B, the current actually then flows through this switch contact through here to a wire that you can just about see the wire here, I think, going around there. Okay, so we've got two separate circuits. Whoops. We've got circuit A, which powers an electromagnet, and then circuit B, which is completed when the armature gets attracted down and touches one of these contacts. Now if you turn the current off in circuit A, then there's a little spring, you'll notice over here, that pulls the armature back up and breaks circuit B. So when you switch circuit A on, circuit B gets switched on. When you switch circuit A off, circuit B gets switched off. The reason you'd want to use this is if circuit B is really dangerous for some reason, either because it's a really high voltage, like something like 10,000 volts or something like that. You might want to use a relay, because if you come into contact with 10,000 volts and the ground, you are going to die. Or alternatively, if it's a really large current, like if it's a huge current like 50 amps or something like that. A current of 50 amps needs very thick wires, and it could get very, very hot, so you wouldn't necessarily want to have to run really thick wires to your switch and have the risk of the contacts getting really hot or vaporizing when you close the switch. So relays have a lot of uses when you want to switch on and off a dangerous circuit by using a safe circuit. So this circuit A can be powered by anything. You could power circuit A with a couple of small batteries, or you could power it with a 12-volt car battery or something like that. So circuit A is a lot safer than circuit B. So it works by using electromagnetism. Now, if you've watched this much of the video and you've got an idea of how relays work, then that's great, and you can stop watching now. However, if you want to know just a tiny bit more about this relay, then do keep watching. This relay is actually broken. Okay, I'm going to rub all this stuff out and show you what I mean. Okay, this picture of a relay is is a broken one, because the armature is actually in the wrong place, and you can see, you'll see what I mean in a minute. The armature actually would ordinarily be in a position, I imagine, here. Okay, so this one's broken. So the armature would ordinarily be here, in this position, in between, with the switch contacts in between. If we call this contact 1 and this contact 2, I imagine it's probably normally in contact with contact 1. Then when the electromagnet's switched on, it moves down, so it's in contact with contact 2, and then when you switch the electromagnet off, it springs back up to be in contact with this. Now this just gives it extra functionality, okay? So let's just draw a coil again and label that circuit A, okay? Now we've actually got two outputs, 1 and 2, okay? So instead of having just two wires coming out of here, we now have 3 wires coming out of here. And the advantage of this is that when you switch circuit A on, output 2 is on, but when you switch circuit A off, the armature springs back up and then this circuit is on. So you can use this to have a circuit that's on unless the circuit A is running, and when circuit A is running, that circuit then gets broken. So this actually gives this relay a dual purpose. Not only can it switch another circuit on or off, but it can also reverse it, reverse the position that circuit A is in. So if circuit A is on, circuit B can be off. Then if circuit A is off, circuit B can be on. So anyway, that's just to clarify that this relay is actually broken, and it does a bit more than just being a very basic relay.